1e.
Do you see the picture of his where all the soldiers cooking?
Just go to
I know.
the airport.
How many people?
I can't remember. I started at the very end.
Okay, what makes this integral improper? The infinity. So replace it with the letter, and then take the limit as b approaches infinity. Now, what's the antiderivative of this? Isn't this the same thing as x to the negative 3/2 dx? Right, because x to the 1 is x to the half is x to the 3/2. What's in the denominator, right? Okay, so the antiderivative, you make the power 1 bigger, put the reciprocal in the front, and you go from 1 to b, factor out the constant. Are you guys factoring out the constants? It's a lot easier if you do it. And then, plug in the top thingy, 1 over root b minus 1. Now we take the limit as b approaches infinity. What happens to this? Well, since the power on the bottom is bigger than the top, it goes to 0. So what's negative 2 times negative 1? 2. And then 2b, is this the one we're revolving it about? Yep, there we go. So number 2, we have the region y equal 1 over x squared. They all look alike, these graphs. Here's y equal 1. So here's the region. It says revolve it about the x-axis. So if you draw the rectangle in, revolve it about the x-axis, what a surprise, it's a disk. Pi times the radius squared dx. The radius is simply top minus bottom, so what's that? 1 over x squared minus 0, 1 over x squared. Add them up from 1 to infinity. Let me make sure you got the right equation, yeah. All right, and then so the infinity is making it improper, so replace it with the letter and then take the limit as b approaches infinity. Now, what do we got? Limit, b approaches infinity, throw the pi on the outside. This is like, isn't this x to the negative 4? Right? Never mind this ln business now. So, make the power 1 bigger, put the reciprocal in the front, and then you go from 1 to b. So negative pi over 3, 1 over b cubed minus 1. Now, what happens if I take the limit as b approaches infinity? What does that go to? Yeah, 0, because the power on the bottom is bigger than the top. It goes to 0. So what do you have? Negative pi over 3 times negative 1? Pi over 3 cubic units. That's the volume of this infinitely long golf tee again. No. On the APA, I'm going to train you in the 4th quarter. The only time you give units is when they say you have to. If they don't say to give units, don't give. Because if you do it wrong, the whole point comes off. Okay, B, now we got to revolve it about the y-axis. Here's 1, so, oh, C then. Okay, so draw in the rectangle. That thing gets revolved around the y-axis. What a surprise, it's a shell. And again, when you have a shell, label this point x, y, yeah? Okay, so 2 pi, radius, height, hopefully we didn't forget that. Okay, what's the radius? What's the radius of the shell? X. And the height is simply top minus bottom. So 1 over x squared minus 0. Add them up from 1 to infinity. Put a letter there, take the limit as b approaches infinity. So what do we got? What do we got? What does this simplify to? 2 pi times 1 over x. Okay, so the 2 pi can be thrown on the outside. 1 to b, and you got 1 over x dx. What's the antiderivative of 1 over x? Natural log absolute value of x from 1 to b, factor out the constant, 2 pi, natural log b minus 0, right? Natural log 1 is 0. And how come I don't need absolute value anymore? Because b is positive. You need to, that absolute value is important now. Okay, what happens now if I take the limit as b approaches infinity? What happens to this? that goes to infinity, right? Because the graph of natural log here, let me remind you, the graph of natural log, as it goes out to the right, just keeps getting infinitely large. It doesn't approach anything.
Wait, so the answer is?
It diverges to infinity, right? Anytime you get this infinity, like infinity minus 0, diverges to infinity. So when you revolve it about the y-axis, you get an infinite volume. But if you revolve it about the x-axis, you get a finite volume. So you never know what you're going to get until you actually compute it.
Mr.
Mhm.
Krabs, can you do 1B?
1b.
Miss Spark,
Boop. Huh?
before you move on, can you do it the washer way too?
No.
It's
Oh,
not
that's
possible.
what I tried. I'm so confused.
Oh, I guess you could.
How would you know
But why?
It's just
Oh gosh, no, let's, no,
okay.
no. 1b. Integral from 0 to infinity dx over x squared plus. Let me just draw this graph for you just so you can see what's going on. If you draw the graph of 1 over x squared plus 1, it looks like this. Yee-haw. So from 0 to infinity, you're trying to compute that area right there. Okay, so this is what's making it improper. Replace it with b and then take the limit as b approaches infinity. Now, do we know the antiderivative of this? Yes, it's on the list. Tan inverse x from 0 to b. Plug in the top term. Tan inverse b minus, what is tan inverse of 0? 0. And then now we take the limit as b approaches infinity. Aha! So what does this get closer to? How do you know? The graph, that's right. See now, if I draw the, remember the graph we did? Or you guys did? See, if I draw the graph for you, you're gonna get it. This is what the graph of tan inverse looks like. So, as the graph is going out to the right, what is it getting closer to? Pi over 2, that's why it goes to pi over 2. And in second semester calculus, this is, when you guys go to college next year, this limit is super important. Now it comes up a lot. The limit as x approaches infinity of tan inverse x. You might as well just memorize it already. And I'll give you another one. What about this? What's the limit as x approaches infinity of x over x plus 1 to the x power? This one comes up a lot in second semester calculus as well. Anybody want to take a guess at that? I'll just tell you, 1 over e. Woo! Comes up a lot. All right, that's it. Okay, so today we move on to partial fractions. Now, I was looking at the partial fractions problems. You guys are lucky. I'm not giving you any quadratic factors. It's all linear factors.
Yay.
Yeah, so this is actually easier, but you gotta understand, when you go to college and take second semester calculus, they're gonna have quadratic factors there. Actually, last year, or the last time we did this, they told me that Mr. Cropsey taught them how to handle quadratic factors, actually. Okay, partial fractions. Let's say you have an integral that looks something like this. What's the integral from 1 to, give me a number. 2, that's kind of simple, but whatever. Dx, and let's say you have x plus 2, x plus 3, and on the top, give me something.
+1. Oh.
Okay, we didn't use it.
5x.
How about 4x plus 1? We didn't use 4x and 1. Okay, there you go. How do you do this? Can I do u substitution? No, u substitution doesn't work. Can I do integration by parts, tabular? No. So what we got? So basically, we're going further down on the list. So the next one would be partial fractions. Can I decompose this into partial fractions?
Yes.
Yes, we learned it last year. So how do you do it? So this is what you got to think in your head. What fractions do I have to add together so that this will be the least common denominator. Something over x plus 2 plus something over x plus 3. Does that sound familiar? Come on, Mr. Krabs, he said you guys are good at this. Yeah, see? What about the other teachers, Mr. Sasaki?
I miss a day.
One day. Mr. Ye, for sure then.
I mean, kinda, but like.
Okay, it doesn't matter because I'm teaching you now. Like, okay, if you add these two fractions together, isn't that the least common denominator?
Oh.
Okay.
Yeah, so what we want to do is we want to decompose this into that, because, see, right now I can't integrate it, but once you decompose it into that, it's easy to integrate that. So now we just have to figure out what are these numbers on the top there. So the first thing you do is you multiply both sides by the least common denominator. So multiply both sides of this equation by x plus 2, x plus 3. Okay, what are you going to get? 4x plus 1 equals a times x plus 3 plus b times x plus 2, right?
Oh. You're multiplying the whole thing.
Yeah, both sides of the equation. Okay, now once you get to this step here, there's two methods you can do. I'm going to teach you both. Okay? The first one is called equating the coefficients. Okay, now okay here. This is the kind of problem you get on the SAT. If ax squared plus bx plus c is equal to 2x squared plus 3x plus 4, what conclusions can you make here? A must be 2, B must be
3.
and C must be 4. Isn't that kind of common sense? That's called equating the coefficients. The coefficient of x squared on the left got to equal to the coefficient of x squared on the right. The coefficient of x on the left got to equal to the coefficient of x on the right, and the constant on the left got to equal to the constant on the right. You guys understand that?
Yes.
Okay, so what happens if I multiply this up? You get 4x plus 1 equals ax plus 3a plus bx plus 2b. So 4x plus 1 equals, now there's two x terms. If I factor out the x, what's going to be left? A plus b. And then the rest are constants because they don't have any x's in them. 3a plus 2b. Okay, so equating coefficients, a plus b has to equal 4. 3a plus 2b has to equal 1. Yeah, this is called equating the coefficients. And then look, you have two equations, two variables, and you just solve it. Mr. Park, this is kind of hard. No, it's not hard. It just has a lot of algebra. So if I were going to solve this, you know what I would do? I would multiply this equation by 2, and you get 2a plus 2b equal 8. And then if I want to get rid of the b's, what do?
Subtract.
You subtract, so you get a equals -7. Once I figure out what a is, plug it back into probably this equation here, yeah? What is b? 11. So that means a was -7 and b is 11. So that's one way to do it. That's called equating the coefficients. Does anybody remember what the other technique is called? Huh?
We only learned one way.
No. The other way is easier, that's why. You know it. You said you learned it well.
What's the only way I learned?
But sometimes, what if you have like 5 letters? Then what you gonna do? Solve 5 equations, 5 variables.
Yeah. We never had more than like 3.
Because you're a regular PC.
Yeah.
Okay, the other way is called the Heaviside Method, named after the English mathematician. What was his name? Was it Robert Heaviside? I think it was.
Heavy.
Okay, now watch this. The Heaviside Method, especially when you have only linear factors, Heaviside Method is so good. Watch this. You see this? You see this here? Watch this. Now, Heaviside said, well, there's so much work to do here. Maybe I can make it easier. So he said, you know what I'm going to do? I'm going to just plug in numbers for x into this equation. So, what would be a good number to plug in for x in this equation?
1.
No,
Negative
2.
7.
no,
0.
no.
3.
Negative 3.
Wow.
Why? Because that will make that thing 0. Okay, so plug in negative 3 for x. Go, right there. Plug in negative 3 for x. Negative 11 equals 0
Negative b.
plus negative b. Therefore, b is 11.
Oh my goodness.
Finish.
What?
Look, you got b equal 11 just by plugging in numbers.
I like it.
Yeah, I know. That's why I can't believe you didn't learn the Heaviside Method last year. Okay, now we have to plug in another number to figure out a. What number do you think I'm going to plug in? Negative 2, because it will make this term 0. So if I plug in negative 2 for x there, you're going to get negative 7 equals a plus 0. Hey, I just figured out a is negative 7. What? So I leave it up to you. You can do equate the coefficients or the Heaviside Method. If you have linear factors like this, Heaviside Method is the way to go. But I don't care how you do it. It doesn't matter.
Does it work if it's squared?
Yeah, except it takes a little longer.
Longer than equating coefficients.
No, so you know what we did in PCH and in BC? So sometimes when you get a mixture of linear and quadratic factors, we do a hybrid of the two. Hybrid. But don't worry, we're AB, you don't have to worry about that. Okay, so this integral becomes what? What did we just figure out? What is A? Where's A? Negative. So negative 7 over x plus 2, and where's B is 11? Plus 11 over x plus 3. So would you agree that this is the same thing as that? Yeah, they're equal. All we did is we decomposed it. But now look how easy this integral is. This is what's the antiderivative of this? What do you mean you forget? Okay, I'll do it. Negative 7 natural log absolute value of x plus 2.
You can do that?
Wait, let me look. Yeah. Because this, oh God.
It's to the power 1.
Yeah, it's the x to the first power, that's why.
What if it's not next to the first power?
Then you can't do that. Then you gotta do like something else. Okay, what about this one? Can I just go plus 11 natural log absolute value of x plus 3?
Yeah.
Yup. From 1 to 2, plug in the top number. Negative 7 ln 4 plus 11 ln 5 minus, now plug in the bottom number. Negative 7 ln 3 plus 11 natural log 4. Okay, let's simplify this. What do we got? Okay, combine these two terms together. Negative 18 natural log 4 plus 11 natural log 5 plus 7 natural log 3. Yeah, I would accept that answer right there. Although, I feel kind of uncomfortable with that one. I kind of rather go negative 36 natural log 2.
Oh,
What?
it's the power thing.
Yeah, because 4 is the same thing as 2 squared, and then you could put the 2 in the front, remember? Property of logarithms. See, so when you decompose it, it's so easy, but the hard part is you gotta decompose it. So, like your teacher told you last year, you know what the key step to decomposing partial fractions is? This part here. You gotta understand how to decompose it. So, if you look at my worksheet, I have notes on the top, and it has examples so that you can follow. Okay, we just gotta do another one. Can I erase?
1 second. Okay.
Hey, this one came out pretty good. Because sometimes, you know, A and B, they don't come out to nice numbers like this. Sometimes they come out, A is negative 3 sevens, B is 13 sevens. But you just gotta work with it. Can I erase now?
Yes.
Okay, so let's do one, see, like, the one we had, see, notice how this is, they're both to the first power? That's like the easiest kind you can get. What about when you have like a repeated factor? Like this. Okay, I'm not gonna do the, what the heck, let's just put in. Integral of something dx, okay, what shall we put on the bottom? X squared times x plus 1. And then what do you want on the top?
X plus 1.
Let's just put a single number there.
3.
3. Actually, now, when you do this method of partial fractions, all you have to do is make sure the degree of the top is smaller than the bottom. So what's the degree of the bottom?
X.
3, yeah? So as long as the top is degree 2 or smaller, you can do partial fractions. So it could have been something like this. 2x squared plus 3x plus 5. Could have been, as long as it's degree 2 or smaller, it's going to work. And then, let's see if you guys remember anything. What happens if the degree at the top is not smaller than the bottom? Like what if it's 3 or bigger? Like what if this was a 4? You guys remember what you had to do? You have to divide before you start. You got to do long division. But luckily, I'm not going to give you those problems. Yeah, I know. If you look at the homework tonight, I don't have any of those problems. So all the problems I give you tonight, the degree of the top is smaller than the bottom, but when you go to college next year, it might not be like that, you know. And then you can say, Mr. Park, you could have taught us more, but he didn't. Even though we begged him not to. Okay, so shall we just keep the 3 at the top there?
Yeah.
Okay. So here we go. How do you decompose this into partial fractions? Okay, so this is what you got to ask yourself. What fractions do I have to add together? You know what? I think we should put a cube here. Let's put a cube there. It'll make it more interesting. What fractions do I have to add together so that this will be the least common denominator? Okay, you know what? I'm just going to tell you. A over x plus b over x squared plus c over x cubed plus d over x plus 1. What?
Oh, yeah.
Well, let me ask you this. If I add these 4 fractions together, what's the least common denominator? That. So that means, so what does that mean? When you have a power here, you have to have that power plus all the ones that come before it, all the way down to 1. You guys understand that? You cannot just do this. You cannot just do this. Can't they just do this, Mr. Park? A over x cubed plus b over x plus 1. Yeah, you can, except that's a fatal error, -8. Yes, if you add these 2 together, that's the least common denominator, but so is this. And if you don't allow for these possibilities, how can you even, what if there are numbers here like 5 and 7 or something? How are you going to get it? Right? You can. So does everybody understand? When you have a power on it, you got to have that power plus all the others all the way down to 1. Yeah.
There's the one that's like ax plus b.
So you did learn it last year.
That is the quadrant.
That's the quadratic factor.
But is that, how would it look like under the denominator?
Okay, so if you have like something over
I'm scared.
x squared times, no, let's just go. X plus 1 times x squared plus 1.
Oh, it's the power inside.
Then you go a over x plus 1, a, plus bx plus c over x squared plus 1.
Yeah.
See, when you have a quadratic factor, see how it's second power, but you can't factor it anymore? Then you put the bx plus c,
Okay.
or ax plus b, or cx plus d. But I'm not going to give you any of those.
Okay.
But you got to be aware that they exist, you know. And then what are you thinking when you see something like this?
Oh man.
Tan inverse.
Oh.
You can lift and separate, right? You can go this over this, and this over this. And that one you can do tan, that's going to be tan inverse, yeah? And then this one over that one is a U substitution.
Oh.
So that's why I'm not giving it.
Okay.
Okay, let's just do this one, and I think that's good enough. So 3 equals, multiply both sides by the least common denominator. Some people came in for help this morning. But you know what they had trouble multiplying both sides by the least common denominator. I don't know why that's a mistake in here. Okay, so what do you get if you multiply both sides by x cubed times x plus 1? Then you're going to get a times,
X squared
that's right, plus b times
x.
x plus 1, plus c times x plus 1, plus d times x cubed, correct? Okay, now what do you want to do? You want to equate the coefficients and solve 4 equations, 4 variables? Or do I want to use the Heaviside method? I think I want to use the Heaviside method. What would be a good number to plug in for x? Negative 1. So if I do that, you get 3 equals 0 plus 0 plus 0 minus d. Hey, we just figured out d is negative 3. Heaviside method. Good, people. What's another good number to plug in for x?
0.
0. So if you do that, you get 3 equals 0 plus 0 plus that one 0. So, well, see, we just figured out c is 3 already. Okay, but see, here's the problem. We've run out of good numbers to plug in, but we still got to plug in 2 more numbers to figure out. We just figured out c and d. We got to figure out a and b. So we've run out of good numbers. You still got to plug in a number, though. And see, that's the beauty of this method. You can plug in any number you want. So what would be the next logical choice? 1 or 573? Because it doesn't matter. Yeah. I thought 1 is going to be 4. What?
574.
Okay, then you got to square it over here. I think one is better. So 3 equals, okay, plug in 1 for x. 1 times 2. 2a. Plus, okay, plug in 1 for x here. 1 times 2. 2b. Plus 2c, but we already know c is 3. So that's 6. Plus, plug in a 1 for x there. Plus d, but we already know d is negative 3. So minus 3 then, right? Okay, so that's the same thing as saying 2a plus 2b equals, no, 0. Divide both sides by 2, a plus b equals 0. So can I solve for a and b yet? No. All we know is that they add up to 0, but we can't figure out what they are yet. So now we got to plug in another number. What do you want to go with? The logical choice would be either 2 or negative 2. Okay, plug in 2 for x, so you get 3 equals, plug in 2 here, so that's 4 times 3, 12a. Okay, plug in 2 here, 2 times 3. Really? 6b. Okay, plug in 2 for x there. 3c, but we know c is 3, plus 9. And then if I plug in 2 for x there, that's 8d, but d is negative 3. Negative 24. So what do we got? 12a plus 6b equals, this is a negative 15, right? Move it on this side. Add 15 to both sides. Oh my goodness. This is negative 15. If I add 15 to both sides, 18. Divide through by 6. 2a plus b equals 3. But I know a plus b equals 0. Subtract. Really?
A equals 3.
Thank you. This is simple algebra 1, people. But a plus b equals 0, so b must be negative 3. There, we figured it out. So even if you do the Heaviside method, look, it still takes work. This is not like everything just pops out.
So b and d equals something.
Yeah, sometimes that happens. In fact, sometimes some of the letters come out to 0, and then you get lucky. Okay, so this integral is the same thing as what? Where's a? 3 over x, where's b? Minus 3 over x squared. Where's c? There. Plus 3 over x cubed plus d. Where's d? Negative 3. So minus 3 over x plus 1 dx. And once you decompose it, hey, they're all 3? Is that right?
Yeah. Or negative 3.
Yeah, I know. Whoa, that's amazing. Okay, so can I do this? The first one. Can I just go 3 natural log absolute value of x? Yes. What about this one? Can I go minus 3 natural log absolute value of x squared?
No.
No, because
So there's
that's
no
x squared. X to the first power, you can do that.
Alright.
So this is the same thing as x to the negative 2, right? So you got to make the power 1 bigger. 1 bigger. Negative 1, and then put the reciprocal in the front. So that's going to be plus 3 then, right? Oh boy. And then what about this one? That's like x to the negative 3. Make the power 1 bigger. x to the negative 2, put the reciprocal in the front, negative half, but there's a 3 there already. So negative 3 halves. And then what about this one? Can I go negative 3 natural log absolute value of x plus 1?
Yes.
Yes, because that's x to the first power. And then don't forget the plus c at the end. Because this is an indefinite integral, so there's no limit, so you have to put the plus c. So this is called the method of partial fractions. Students seem to like this one, and then tomorrow we got trig substitution. Students don't like that one as much.
Wait, so our quiz tomorrow?
No, the quiz is on Wednesday, isn't it?
What?
Oh no, it is tomorrow. It is tomorrow.
So then, it's just the 3 lessons that we learned.
No, it's not even on this. It's only
The 2
on
lessons we learned.
it's only on L'Hopital's rule
And the infinite.
and the improper integrals.
Yeah.
So that's a 60-point quiz now. Don't worry, I told you. What did I say? I'm giving you 20 points free, right?
Yeah.
Okay, we're done.
Who's gonna say it?
You guys have 20 free. No, don't say it. No, this stuff you guys gotta do. In fact, you know what you should do now to cement it in your brain? Do at least one problem now. Why is that funny? No, for real, that's how you keep it in your head. Because if you don't do anything, and then not gonna do anything to see, once you fall asleep tonight, a lot of it's gonna be gone. No, for real. So that's why you gotta do at least some before you fall asleep tonight. You guys don't know how the brain works?
You don't sleep. I don't take some college yet. No, I mean, what's this?
Look, I'm just asking you to do one problem. That's gonna help immensely.
Also cement like the top.